Hello and welcome. My name is Matthew Hershey. I'm from Duke University, and today we'll be going over Shiny apps and how we can use this new and exciting sort of age we live in of data exploration with this really powerful package that can lay over the R environment. Today, I'm joined by Akshay Bareja, and together we'll be starting with zero entry, very basic, very early instance and toy example of a Shiny app. Akshay will then go into some of the uses of Shiny apps for data analysis and data exploration. And then I will show you some of the more powerful features of the Shiny app. In particular, one feature that was very recently released called Shiny Modules, which helps organize a sort of growing and complex Shiny app. So today we will. So today we're joined by Akshay Bareja. Akshay, hello, how are you?
Hi Matt, doing well. So yeah, like you said, I'm going to quickly introduce Shiny, which is an R package, and go over how to build a really simple but useful app that we can use to interrogate a big data set.
Okay,
Yep.
excellent. The floor is yours.
So we just begin by going over what Shiny is. So Shiny is an R package, and it allows us to make web applications that we can either run from within our studio itself, or we can embed in a web page. So these can be standalone apps, or they can be hosted on a web page. So I like to think of our Shiny as our version of Tableau. So this is an example. These are examples of Shiny apps you can make. So this is a page from our studio itself, which has a collection of a bunch
Akshay,
of. Yes.
let me just chime in for 1 second. I'm getting a lot of feedback. Do you have the YouTube page open, or do you have? I'm getting a lot of echo. I don't know if anyone in the comments could also then just chime in and let me know if they hear that echo
I
as
don't
well.
have YouTube
Okay.
open right now.
All right. Let's just go ahead and people can chime in if they're getting it also.
Okay. Right. So this is on this web page. You can see that there are various kinds of Shiny apps you can make. And this list of, or this gallery of Shiny apps can be found on the RStudio website. So you can make really simple apps like this. This one called Faithful, and this just allows you to plot a histogram. And what Shiny allows you to do is you can adjust certain parameters, and you can get a dynamic output. So that's an output that changes. And we can see that we can do all kinds of things. We can use Shiny to make a chat box, apparently, and various additional things. So how does the Shiny app work? A Shiny app, or at least a basic Shiny app, it consists of just three components. You have a user interface section, a server section, and a function that launches the app. So when a user makes a change or enters some input, the output gets changed accordingly. So let's build an app. So we're going to use the same microarray dataset we used for the last meetup. This is actually a smaller version of that, just so that the app runs quickly. And this app's a really simple app. It has a drop-down menu of genes, and the user can select a gene and then get a corresponding graph that plots the expression of that gene in this case, 6 samples. So this is what the app looks like. We have this drop-down menu. I've called it outlier detector. It's not technically detecting outliers. It's just useful to see if there any of your samples, the expression is unusually high or low. So you can see this is a simple ggplot output on the right. And on the left, you have a drop-down menu that allows you to select a gene. So in this case, the default is COPG1. And if I click on this drop-down menu, I can, for example, click on PSPH. And we'll see in a few seconds, we see that the graph updates. And we can also, for example, just enter a gene name that has to exist within this list. So ATG5, for example. And so this is useful because you can see that 5 of the 6 samples have pretty similar expression, but 1 is off. And maybe that's a genuine outlier. Maybe that's because of a technical mistake, who knows? But you can see how we can quickly interrogate a very large data set of thousands of genes just by using this interactive interface. So let's look at the code. I mentioned that a typical Shiny app consists of three components: a UI or user interface component, a server component, and a function that launches the app. Now, all of this code can be put in just one R document. We can call it like app.r. And that's typically what I do. This code can also be split across multiple R documents. That's also acceptable. So if we look at the user interface code, the top 4 lines, it's kind of, I like to think of it as in R Markdown when you, it's sort of like the setup chunk. So you have to call the library function for all the packages that you will be using. So in this case, we have to use Shiny. So it's library Shiny, and we'll be using some of the tidyverse functions. So it's library tidyverse. And in this particular app, since we're using a dataset, that dataset needs to also be located in the same folder that contains your app.r script. And if you update your meetup repository, you will see that the code for this application is found in the August folder, and you can just run that app on your machine. We use the read_CSV function to import this df.csv. So this data frame contains expression information for the 6 samples and the gene names. And the thing that we'll be changing or getting the user to change is the gene name. So we use the pull function to pull the gene names that are stored in this column called gene.symbol, and we'll save it as a gene's character vector. So that's all the setup. So now for the user interface side. So typically for a simple app, the user interface side begins with this fluid page function. And that's really because what you're making is a web page which is fluid and dynamic and contains things that are changeable. So for example, a drop-down menu. So the fluid page function allows you to include components like that. So it always, or typically a simple app typically begins with this fluid page function. And within that, we can put in a few functions that define the layout of our application. So if you want a title, you would just do title panel and give it a name, comma, and then we define the layout of the page. So we use this function called sidebar layout. And within that, this is a really simple function that just has 2 panels. We have this side panel and this main panel. So the side panel contains the drop-down menu that the user can use to select a gene, and the main panel contains the output plot. So we see within the sidebar layout, we have a sidebar panel that has this drop-down menu option, and a main panel that plots the plot. So if we want a drop-down menu, we use another function called select input. So this is one of the slightly challenging aspects of Shiny when you are first introduced to it, that you have all of these nested functions. But when you think of it from a top-down approach, it's actually not that complicated. It's just getting used to some new functions. So if we look within this select input function, so our drop-down menu, let's first take a look at just this uppercase G gene. All that's doing is creating this name here, gene colon. And since this is a drop-down menu, we need to populate this drop-down menu. So to do that, there's an argument called choices, and we make choices equal to genes. And genes is what we defined earlier on. That's just a character vector that contains a bunch of gene names. So you have gene, and then choices, and then you can see you can select one of the genes that's within your choices. Now this part here, this lowercase g gene, this is where things get a little bit tricky, because so far everything we've shown you in every meetup and bootcamp has been linear. You start at the beginning and you end at the end. With Shiny, it's a to and fro motion. So this lowercase gene, what it allows us to do, or what it allows the app to do, is it allows the app to take a user's choice, so in this case a gene name, and as I've written here in this comment, it smuggles that information, so the gene name, into the server side, which we'll see in a second. So that's how you go from the user interface, which defines the layout of your app and gives the user an opportunity to do something, in this case, provide an input, that it can then send via this object that we've called Gene to the server side. So let's take a look at the server side. So the server code, which in our app.r script just sits below the UI code, always begins with this function input output and then curly braces. So let's, if we look at it from an inside out perspective, we can see that it's mostly just simple ggplot code. What we do is, so if we start here at this df, we take df, which we defined earlier, the data frame, and then we pipe it into a filter function. So in this case, if I, for example, wanted to plot that expression plot for the gene ATG5, I would just do gene.symbol equals ATG5. Now that's how you make a static ggplot. In this case, since you want the plot to update every time the user makes a change or a choice, you can do that by using this input $sign. And what follows the $sign is this object called gene, which we defined earlier. So that's what represents the user's choice. And this input $sign is just a convention. It's just a way of, as I said previously, smuggling the user's choice into the server side. So that's it. So if the user chooses ATG5, I think of it as the input $sign gene getting replaced with literally ATG5. And then the user selects IGF1. If the user selects IGF1, this input $sign gene will then be replaced with IGF1. And then the rest of this, I won't spend too much time going through this. It's really just reshaping the data frame so that we can then use ggplot and geomepoint to make the resulting plot. All of this is just things you've seen before. Now, we have to take this code and put it within this function, render plot. We have to put it within a render function because this is dynamic code. It's not static code. So we need some kind of function that can handle this, this sort of dynamic code. And in this case, the particular render function we're using is render plot because that's what this code is making. It's making a plot. If we were making a table, we would do render table and so on. So we take the simple, very familiar ggplot code, the only difference being this input $sign gene instead of actually hard coding the gene name. And then we wrap it within this render plot function, and we take the output of that and we assign it to this output $sign plot. And the reason we do that is just as we had this input $sign gene as a means of sending information from the UI side to the server side, we have this output $sign plot that takes whatever the server side has done, takes that output and sends it back to the UI side. Now, when it sends it back to the UI side, let's just go back. It sends it, so we see that it's called output $sign plot. So the plot, there has to be a corresponding plot, lowercase p plot, somewhere in our UI code. And we can see that it's here. It's within this function called plot output, which is also within this function called main panel. So all this is saying is the application now takes this object called plot, which is the result of what the server did. So that's running the ggplot code. And then it plots that object using this plot output function, and it puts that plot in the main panel. So we get this. So the logical flow is the user makes a choice. So that's here, this drop-down menu. This choice is recorded by the app as gene. The app sends this choice, this information to the server side via this input $sign gene. Something happens. In this case, that something is making a ggplot. That something, the result of that something, gets assigned to an object called plot, and that gets sent back to the UI side over here, so that we get a plot. So we start at lowercase gene. We go to the server side via input $sign gene. Something happens. The output of that something gets saved as output $sign plot, which then gets sent back to the UI side. So it's make a change, go to the server, come back, you see an update. And that's it. So that's the UI side. and the server side. And now, and oh, I forgot to say, this UI code has to be assigned to an object called UI. And this, all of the server code similarly has to be assigned to an object called server. So once you have your UI and server code defined, to launch the app, you just use the Shiny app function that in this case takes 2 arguments, UI and server, and then you run the app. If you wanted to add, so that's just to make this simple app to look at expressions, levels of genes for different samples. Let's say I wanted to add another reactive element. So in this case, this is the app slightly updated. So you can see here that it now has a title. And that title says expression levels for gene : COPG1. Now, if I choose another gene, or if I put in another gene, let's say ATG5, I get the corresponding plot, and you can see that the title has now been updated. So now it says expression levels for gene ATG5. So let's see what I did to add this additional reactive component. For the UI side, it was really simple. The only thing I added, as you can see here where I've commented new code, is this bit. Since I now have a new text output, instead of using the plot output function, I use text output. And I have this object called text, which I'm getting from the server side, as we see here. So on the server side, again, most of the code is the same as I showed previously. The only bit that's different is this output $text. And we see, again, working from the inside out. All I've done is use this paste function, and I have this string, expression level for gene, and a comma, input $gene. So the input $gene, again, is the same as the input $gene here. I am smuggling in the gene name. So if this were ATG5, the output would be expression levels for gene : ATG5, and so on. And since this is a reactive component, it has to be wrapped within this render function. So in this case, it's render text. That gets assigned to an object called output $text, which gets sent back to the UI side into this slot here. And this text output tells Shiny that I want this to be output as a text. That's it. So if you want to run the app from within your machine, make sure that your project is up to date. And you go to the August folder, you'll see a file called app.r. You open it, and on the top right-hand corner, you'll see something called Run App with a green play button. You click play, and it'll launch the app from within RStudio. I thought I would spend just a minute talking about this concept of reactivity. So again, there's this really helpful post on the RStudio website called How to Understand Reactivity in R, which goes into great depth to describe this concept. But briefly, reactivity is not like switching on a light bulb. So it's not like we're turning a switch on and seeing light come on. What is really happening is if you run your app on your machine, you'll see that while your app is running, you can't use RStudio. You see a stop button. So it's constantly running. So what the Shiny app is doing is it's every few microseconds, it's assessing if there have been any changes in its state. And those changes are user defined. So if there are no changes, it doesn't do anything. If you make a change, after a few microseconds, Shiny will notice that you've made a change and then make the relevant update. So it's not like turning on a switch and then something happens. It's you make a change, wait a few microseconds, and Shiny, which is constantly checking its state, notices that change and then makes the relevant change. And it's important to know this because in this case, this is a very simple app, but Matt will show you a much more complicated one. And this sort of magic trick falls apart if there's too much of a latency. So that's just something to keep in mind when you're making more complicated apps. And I wanted to end just by showing an app in the wild. So if I click on this link, it's becoming more and more common to for publications to have corresponding or accompanying Shiny apps, especially publications that have gigantic supplementary sections, which would take forever to navigate. In lieu of that, or actually in addition to that, people have started making Shiny apps. So this is an example of a paper that was published last year by Tony Whiskare's group, looking at the profiling the plasma proteome of humans across the age spectrum. And so this is just a brief description of the paper. But if we go here to the aging plasma proteome, This should take a second to update. You can see the default gene. Again, they have a drop-down menu, just like we did for our simple app. In this case, the default gene is GDF15. And you can see you have, they've plotted the log10 relative fluorescence units of this protein across different ages. And we can, so in this case, they've plotted a Loess curve. We can make it a linear regression line, because that's what they've done. They've performed linear regression. And they did this in both men and women. So if we wanted to see if there were any differences between men and women visually, we can just do it, click on this per sex radio button. We see that there is. Earlier in life, women have higher levels of GDF15, but later in life, they have lower levels. And you can also use this slider to, if you wanted to just focus from on the ages 80 to 100, you can do it like this, and you can see how this very rapidly and dynamically changes. And you can also add fancier features, like let's say you have this and you wanted to include this plot in your own publication, you can just download it as a PNG file. And that's it. So, Matt, back to you.
All right. Thank you, Akshay. I will take a few minutes now and show you one of the projects that we're working on in the lab. This is a project that we call Data-Driven Hypothesis. This project is a Shiny app that is trying to integrate, or sort of hopes to integrate several different data sources in order to allow a user to query large publicly available data sets, just like Akshay was showing, but then tries to put them together in a sort of useful way that then might be supporting hypotheses that we can go test. So we call this data-driven hypothesis. So I'll just show you a simple example here. So we can take a gene, and I like to joke that my favorite gene is MDH1. MDH1 is a gene that shares my initials. And so we can then click on this, we can search a gene, and what's happening underneath is that we're gathering a lot of different information for this gene. And so some of the information that we're gathering is gene summary information, and this is by RefSeq, so it's just scraped from the RefSeq database. We can then also start looking at some data provided by the Broad Institute. The Broad has a impressive and massive effort to identify cellular dependencies across several different cell lines. So what that means is that they are systematically marching through several cell lines and knocking out every gene in the genome and asking what's the functional consequence. And so what we can do is we can look and we can start generating some plots on the fly. This is a plot of the cellular dependency of MDH1. We can then zoom in on it, and we can see that this is a gene, MDH1, and the level of the dependency of this. I won't get too much into the details of the science behind this. If anyone is interested, they can go to datadrivenhypothesis.org and then click on the methods, and it describes everything that I did. But what I want to show you now is the code that underlies this. And there's two different versions that I want to show you. So the first version that I want to show you is a version within RStudio that's live right now. And so I want to see if I can switch this over to show you the DDH project. So what we're looking at right now is the RStudio for the data-driven hypothesis. And there's a couple of things that I want to point out. So the first is, even though this is a much larger and more complicated app than the ones that Akshay showed you, there's a single app.r file. And in this app.r file, we have a lot of different things going on here. So we can start by calling all of our libraries, just like we would normally do. We can then come down a little ways, and we will then load the data. So we regenerated most of the data here, so this is where we load data. We can then go down a little further, and we start to add some functions. I've pulled out the functions here and put them into specific or separate R scripts. And when we come down, the examples that I want to show you are when we build the pages, just like Akshay showed you when he built the pages. So here we have a page, and this is called Gene Summary Details. This has a title, and this has some information. And this is then put into a page. And so this is called gene summary details. We've got some pathway summary details and so on. When I keep scrolling down further, I want to show you where we have corresponding server files for these. So this is actually the main page. We've got a couple of different modules, but this is the main page here where we have a PNG of our image. We've got our title. We've got some information about that page. And then finally, this is the details page. This shows the gene data. So we call this detail page. And then we have tags and some more information. And this is all sort of standard Shiny code. And when we come down a little bit further, we have multiple menus and so on here. When we come down further, this is where we start our server information, our server file, and we can then find the corresponding server files for all of the information that we had above. So we've got some examples and pathways, and we've got our output $, just like Akshay showed you, output $, and then the name of our output file. We've got some output text. This is rendered text, just like, again, Akshay showed you with his gene example. And the last thing that I want to show you is that the corresponding file for each of these pages is much further down. If we keep going down, you can see that this is nearly 800 lines of code. Okay, so what we've done recently is change the organization of this so that we now have a modules. So instead of having an app file that's 800 lines of code, we now have an app file that is closer to 400 lines of code. So let me just switch over and show you this next example. Okay, so this is our working version of this. So this is still in development. But I want to show you a couple of things here. So this is the same app.r file. But you can see that we're at the bottom of the file, and this is only 400 lines of code. So you might ask yourself, where did the other code go? Well, it turns out that we've carved it out of this, but we've now reorganized this app so that all of the Shiny code is in these Shiny files. So for example, here's a table that we made. So we can make something that's called a cell dependencies table. And the nice thing about this modular Shiny sort of new way of working is that the server file for this is right next to the file that we use to create our pages. So the nice thing now, when you start getting much more complicated and much richer types of Shiny apps, is that the organization becomes much more difficult. So this new way of working with modules pairs the input information and output information together, or the UI information and the server information together. So instead of separating them, we keep it together, and I put this in a simple R script by itself. And then what we can do is we can see the same thing is here. We have a similar genes table, similar genes table server, and so on it goes. So these modules have a couple of nuances, such as this what's called a namespace conflict. And so one of the things that you need to do is wrap most of your input IDs in this namespace function. The details of how this function works aren't super important for our purposes here, but the way that you can think about it is that the namespace is going to make sure that having these different elements right next to each other are not going to conflict. So if we take care of this namespace issue with a couple of these simple functions here, then what we can do is we can really simplify this app and organize it. So with that, we want to thank you for sort of following along today. I was able to, during Akshay's presentation, I was able to get the files that Akshay was talking about pushed to the GitHub repo. So if you want to follow along, or if you want to go back and look at the df.csv file that he was talking about, that's all located on GitHub, so you can do that now. So I want to sort of wrap up and sort of share my perspective, is that whether it's scientific papers with overflowing supplemental data sets, or whether it's your own data that you really want a way to explore, the power of having this in R and being able to wrap that R code in Shiny means that we are now able to explore our data and perform what we call exploratory data analysis in a much more intuitive and natural way. And in fact, you can share some of these apps with perhaps your colleagues who are less technically competent, and they then can perform exploratory data analysis on these as well. So with that, thanks for joining us. We'll be back again next month. We'll be doing some data visualization and cleaning up some data visuals. So until then, thanks for joining.